All right, hi everybody. Welcome to part 3 of chapter 7, section 1. This will be the final video in this section. So today we're going to talk about our last type of naming of different types of compounds. This one is referred to as molecular compounds because with molecular compounds, they're only going to be composed of nonmetals, and they can be composed of 2 or more nonmetals. Now, the difference between binary molecular compounds and something like a polyatomic ion is the fact that the binary molecular compounds that we're going to discuss have to be neutral in nature in order to be concerned or in order to be considered this type of compound. So, molecular compounds are going to be composed of 2 or more nonmetals. That's the first thing. The second thing to know is that when we name molecular compounds, we are going to use prefixes to do so. And it does say the old system, but that's also the current system that we're going to use. So down here we see 3 different examples. All 3 of them have a single carbon, so they all start with just the name of the first nonmetal that is in the formula. And then they get a prefix on the second word. So mono is going to be meaning 1. So the CO gets a carbon monoxide. Carbon with 2 oxygens gets carbon dioxide. And then carbon with 4 chlorines, again, we're going to drop the ending of the second thing. So INE becomes IDE. And we're going to get tetra because that means 4. So we're going to follow some of the rules from the previous type of naming, and we're going to introduce the prefixes idea. So here we see a few more examples. We've got the different prefixes. Mono, di, tri mean 1, 2, 3. Then you've got tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Now, something to note is that in all of these examples, you see that the first element that's listed is always named first, and it gets its full name, so we don't drop endings or do anything to the endings. The second element is the thing that always gets a prefix no matter what, and the ending of the second element gets dropped, and we add that IDE, just like we talked about in previous types of compound naming. All right, the second thing to notice is that there is a special rule for how to name things that have more than one of the first thing that's listed. So, if there is only one of the element, there is no prefix. So never should you start this type of compound with the term mono. Never. Never should you start with the term mono. Okay, just kind of keep that in the back of your head. You should never be naming a compound with the term mono first, or the prefix mono first, for any of these types of compounds. Now, if it's not a single atom and it's anything other than one, then it does require a prefix in front of the first atom. Okay, so here we see neptunium. We do not change the term of the element, so we don't change the name of the element. It's going to stay neptunium. All we're going to do is add a prefix in front. Because this one has 3, that prefix is tri. And then the second one, of course, you're still going to do the thing that you were doing before, or we drop the ending and we add IDE. The second element always gets a prefix, whether it's mono or di or whatever it is, the second element always gets a prefix. All right, next is just going to be some different examples. So here we have dinitrogen monoxide. It has 2 nitrogens and 1 oxygen. We have trilithium nitride. So depending on how they're listed is how we name them. Okay, so how we write the formula is how we name the element. Okay. All right, so from here we have a couple of examples. The first one is As2O5. So what's the name of that? It has 2 arsenics. That's what the 2 after the AS means. And then it has 5 oxygens. So we're going to look at our prefixes, and 2 is going to be di. 5 is going to be penta. Remember that if it's anything other than 1 atom in the first part of your name, that you're always going to put a prefix. So this one gets a prefix of di. And the second atom, oxygen, is going to get its ending changed to "ide", and you're going to insert the prefix in front, which is going to be penta. So you're going to do pentoxide. So diarsenic pentoxide. Remember that the first atom does not lose anything from its ending. You just kind of name it as it's on the periodic table. In the second example here, we were told oxygen difluoride, and we were asked to write the formula. And here we see that the oxygen that comes first, since there is no prefix, must mean that there's only one of them. So we're going to write O, and then we're going to put a subscript after the fluoride. We know that fluoride is F, and there's 2 of them, so it's OF2. All right, so here is our first lecture question for this video. go ahead and answer your question. Remember, you should be writing A, B, C, D. When you're done, you can move on. All right. So, a few more topics that we need to discuss. First is just this idea of covalent network compounds. Similar to the covalent molecular compounds, these are going to be named the same way as the molecular compounds we just talked about. So we're going to use prefixes. We're never going to use mono on the first word. We're always going to drop the ending and add IDE. So covalent network compounds, the difference between this and a molecular compound is just that these are not going to be individual molecules. Instead, what we're going to represent these different huge networks of compounds with is our smallest ratio that we can write. And that smallest ratio ends up being the formula that the compound gets. From there, we have two more concepts, the acid and the salt. An acid is considered a type of molecular compound. Most of them are going to be what we call oxyacids or binary acids. Binary means two, so two elements. Usually one of those elements is hydrogen and then the other is a halogen, meaning group 17 element. The oxyacids are going to be ones that typically contain a polyatomic ion with a hydrogen attached to the polyatomic ion. A hydrogen, more than one hydrogen is also typically. It really depends on the actual polyatomic ion and its charge. So the term the term acid is typically going to refer to something in water. So we don't just kind of say, oh, hydrochloric acid. What we say is that it's HCl. So the molecular compound HCl that is dissolved in water becomes the acid hydrochloric acid. So things that are referred to as acids are compounds that are dissolved in water rather than just the compound by itself. Okay, so kind of put that one in the back of your mind. And then like we said, the polyatomic ions are going to be the ones that are very commonly attached to hydrogen atoms in order to make some of the acids that you're familiar with. So you've all heard of sulfuric acid before, you've all heard of nitric acid before, you might not have heard of phosphoric acid before, but those are all common acids. Some of them are very strong, so these two are very strong acids, this one's a little bit weaker, and they're all made of the polyatomic ion with hydrogens attached to balance out the charges. So for instance, this sulfate gets 2 hydrogens, and it gets that because the charge on the sulfate ion is 2-. Okay, and you can notice that there's an interesting link between how these acids are named and the polyatomic ion. So what we do is we take the name of the polyatomic ion, we drop the 8, and we add ic. So it becomes sulfuric acid because that doesn't, if you just said sulfic acid, that would be weird. So this one actually keeps the whole name, but a lot of times what we do is we drop the 8 and we add ic acid. So phosphate becomes phosphoric acid and so on and so forth. So that's the common way to name. Another type of compound that is something we've actually discussed in detail in this chapter so far is the idea of a salt. So the ionic compounds that we talked about so far that require a metal in the cation form and a nonmetal in the anion form or a polyatomic ion in the anion form are going to be referred to as salts. The thing that distinguishes a salt from an acid is that when a salt hits water, it dissociates into ions always. So something like sodium chloride will dissociate into sodium and chlorine ions. From there, the difference is really going to have to do with a lot of deeper science that we aren't going to cover quite yet. Okay, so just kind of giving you an idea of how these things are named. Naming acids is going to be kind of a different process, if you will. We're not going to worry too much about naming them, but what I want you to recognize is that the way we name an acid is very similar to the way that we name our polyatomic ions. Okay, all right, so here is your next question. So you have question 7 and question 8, and that is going to wrap up this video. So if you want to go ahead and pause it and answer this question, when you're done, go ahead and hit play and you can move on to question 8. Again, this is the end of the video. So once you're done with this question, you can go ahead and you can end. Have a great day.